In this lesson, we're going to be taking a look at solving two-step equations. So these are equations where you generally have to do some adding and subtracting and some multiplying and dividing in order to be able to get the variable by itself. So we're starting off with the problem that you see up here on the screen. And the first thing I want to do is kind of give a broad overview about how we start solving these equations with multiple steps in them. And I'm doing that by first taking a look at Pemdas. And yes, multiplication and division are actually on the same line, and addition and subtraction are actually on the same level as well. So multiplication does not normally get done before division. They both get done at the same time. But I bring this up now because when we are solving equations, we are undoing the equation, which means we're actually using PEMDAS in the reverse order. So when we're undoing an equation like this to solve it, the very first thing we want to do is get rid of any addition or subtraction that we see in there. And then we'll move on to dealing with getting rid of the multiplication division. And then we get rid of any exponents at that point and so on. So in this particular case, if we're going to be solving this equation for q, then the very first thing I need to do is get rid of the addition subtraction. In this case, that means getting rid of the plus 5. And so I'm going to be subtracting 5 from both sides in order to be able to get rid of the plus 5, because we're always undoing whatever is currently there. And I know that that's what I have to do because both the 4 and the 5 have to be gotten rid of out of that side in order for the q to just be left by itself. And we do get rid of the addition subtraction first. All right, so if I subtract the 5 from both sides, 29 minus 5 is going to give me 24. And then the 4q is unaffected. And then the 5 minus 5 is 0. So technically we'd have to write like plus 0 out there, but of course 4q plus 0 is just 4q. So we don't need to actually write that in there because it went away. But I do want you thinking about, does it actually go away each time? Otherwise you can just get on autopilot and you do something even though it's not right. Whereas if you thought about, did it work, you'd catch it. All right, we've done one step. Now we're just left with one thing left to do. Now it's a much easier equation to solve. Because in order to get the q by itself, we have to get rid of the 4. This is currently 4 times q, and therefore, in order to get rid of the 4, I have to divide both sides by 4. Because whatever is currently being done, we are undoing it. So since we're currently multiplying, we will undo it with division. We're doing the opposite operation there. All right. So next up, I'm going to do the actual division now. So 24 divided by 4 is 6. And then the 4q divided by 4 would be 1q. But we don't actually have to write in the 1 there again because 1q is just equal to q. And so we can go ahead and just get rid of that 1 there and just write it as 6 equals q. And with that, because our entire goal was indeed just to solve the equation for q, I've done that now. You might be wondering, yeah, but q's on the right side. Isn't the variable supposed to be on the left side? No, it doesn't have to be. I know when you're first getting into algebra, that is definitely what is most common to see. However, our whole goal is just to figure out what q equals. And even though it's written on the right-hand side of the equation, I still know that q equals 6. And so whichever side it's on, we still know what it equals, which is our whole goal. So we are good there. We know that q equals 6. All of our other problems like these are going to operate in the same way. We're going to start by getting rid of the addition and subtraction. So looking at this problem, if I'm going to try to solve it for t, the part that's in the way of the t being by itself right now is the 4 and the 5. I want to get rid of the addition subtraction part first, so that means getting rid of the 5 first. So right now it's subtracting 5. In order to undo that, I'm going to add 5. So I add 5 there, and I add 5 there. Remember, we're doing it to both sides of the equal sign. So having done that, then on the left-hand side, I'm just left with 4t equals, and then I do the negative 29 plus 5. Do pay attention to your negatives here to make sure you're doing the operations correctly. Take your time with it until they just come totally naturally. And double check yourself as much as you can. Negative 29 plus 5 should give us negative 24, because we're starting down at negative 29 and we're going up from there. So we're getting less negative. All right, last up, I am still trying to solve for t. The 4 is currently in the way of that, so I need to get rid of the 4. Since right now it's 4 times t, I will undo that by dividing both sides by 4. And when I say both sides, I mean both sides of the equal sign. This imaginary wall that goes down from that equal sign is what you are always doing when we're talking about both sides of an equation. That's how we separate the two sides. It's always along the equal sign. All right, so when I divide both sides by 4, 4 divided by 4 is 1. So on the left side, we're just left with 1t, which is just t. And then on the right side, I do negative 24 divided by 4, which is a negative 6. And then that one is now done because we figured out what t equals. In our next example problem here, we have to pay special attention to that negative 2, because if we don't stay really careful about how we deal with that, we could potentially get tripped up. All right, so then as we jump into this one, we can see that we want to get rid of addition and subtraction first again, right? Well, right now, this is the addition that I would be getting rid of. And I want p to be left behind on this side after all is said and done. So if I'm going to undo this, that means I'm trying to get rid of this negative 2 out of that side. And so since I am undoing addition, that means that I would be subtracting from both sides. But be careful with it. We are subtracting, but you'd actually be subtracting negative 2 from both sides. Because what are we adding to 4p? We're adding negative 2. Therefore, in order to get rid of it, we would subtract negative 2. And yes, I need to do that to both sides of the equal sign. And so when we do that then, I'm going to do 30 minus a negative 2 on the left side. Remember that minus and negative, whenever you see those two right next to each other like that, they cancel each other out. And it ends up working the same way as if it was plus a positive 2. And so 30 minus a negative 2 then will equal 32. And on the right side, the negative 2 minus the negative 2 would be 0. And then we're just left with the 4p. As a side note here, if instead of writing minus negative 2, if you had written plus 2 on both sides, yes, that does mean the same thing. And yes, you are perfectly welcome to show your work that way. It's just a different way of thinking about the same basic problem. All right, last up. I am still trying to get p by itself. Therefore, I need to get rid of the 4 that is currently on the right-hand side. And since it is 4 times p, I will have to divide by 4 to get the p by itself. So we divide both sides by 4. That leaves us on the left side, 32 divided by 4 is 8. And then that equals just p, because 4 divided by 4 is 1, and therefore cancels itself out. And finally, we're going to end with this example problem. And this one's the last one because it's the trickiest of all the problems that we've been talking about here. Because in this case, we see that we are currently subtracting. And so you may well be thinking then, okay, so in order to solve this then, I should add 9 to both sides. But that's not quite going to work. And let me show you why. If I actually try doing this, adding 9 to both sides, when I do this 9 plus 9 right here, that would actually be 18. And so we'd have 18 minus 4n equals a positive 2 at that point, which did not help us any, because our whole point in trying to do something to both sides is to get rid of the 9. So, but it's subtracting. Why didn't that work? Because what's actually being subtracted here is the 4n. We aren't subtracting the 9 from the n, we're subtracting the n from the 9, and that changes things up a little bit. And so to help you just kind of process through what is really going on here, if that part of it does tend to give you trouble, you could start by rewriting your equation as 9 plus negative 4n equals the negative 7. By writing it now as plus the negative, it's now much easier to see what is actually happening here. Because since the 9 is positive, that 9 is actually being added to the n. And since we do have that positive 9 there, so it's being added, we will get rid of the 9 out of the left-hand side by actually subtracting 9 from both sides. And remember, when I say both sides, I'm talking about both sides of the equal sign. So make sure you do it once on the left side and once on the right side. No more, no less. So then, on the left side, now when I do 9 minus 9, I'm actually thinking that through, and I'm saying, is 9 minus 9 0? And the answer is yes, so that means the 9 did cancel out. It's gone now. And all we're left with then is negative 4n. And then that's going to equal a negative 16. So notice that by writing it this way first, with the 9 plus negative 4n, we not only figured out that we should be subtracting the 9 instead of adding it, but we also figured out by doing that, that after we got rid of the 9, that we'd be left with a negative 4n. All right, now that I have it to this point, solving it should be, I hope at least for you, fairly straightforward, because now once I've gotten to this point, I just see I have negative 4n equals negative 16. And to get the n by itself, I have to get rid of the negative 4. Remember that that is negative 4 times n. And therefore, to get rid of it, I'm going to divide both sides by negative 4. All right. That then leaves us with n equals, on the right side, we're doing a negative divided by a negative, which is a positive. So that will equal a positive 4, because 16 divided by 4 is 4. That then is our final answer, and we're done.